All right, hi everyone. This is FRQ 2015, question number 1. And because we are in the quarantine and we won't be able to use a calculator to attack this problem, I've been trying to figure out how to get you guys to really see what the understanding is behind it. So don't worry about the computation, but worry about how do you know which equation to use. And so we'll talk about that. All right, so it says the rate at which rainwater flows into a drain pipe is modeled by this function, okay? Where RFT, cubic feet per hour, is measured in hours from 0 to 8. And it says the pipe is partially blocked. It says allowing water to drain out the other end of the pipe by this equation. So what's happening right now is we have water that flows into the pipe, and that's going to be right here. So you're going to say this flows in. And then it says it's partially blocked. So the water that is coming out the pipe is going to be right here. So this is going to be the water that's coming out. And then lastly, it says there are 30 cubic feet of water in the pipe. So visually, what I was thinking was, if you had a little picture really quickly, say this was a pipe. Already in the pipe, there's 30 cubic feet of water in the pipe. And then you have water that's coming in at a certain rate, like how fast. So that means they gave you a rate. So if we're talking about first graph, second graph, third graph, if we're talking about the first derivative, this right here is already in the first derivative. This is how fast the water is going in. And this one is talking about how fast the water is coming out. Okay, so that's the pieces of information that they gave you. And they said from 0 to 8 hours. So let's look at question A. So question A says, how many cubic feet of rainwater flow into the pipe during the 8-hour time interval? So right here it says, how many cubic feet of water? It doesn't say how fast or what's the rate of water that flows in. It says how many. So it wants to know the first equation. All right, so that's our original equation. What's the water that flows into the pipe? Well, that's going to be RFT. This is how fast the water is going in. So I'm going to write this equation right here. So this is RFT equals 20 sine of t squared over 35. Well, this is how fast the water is going in, but it asked us how much cubic feet of water went in over the whole course of time. All right, so that means we're gonna need to go backwards because we know this is how fast, so we need to know how much. So we're gonna say, what is the integral? Anytime we're talking about total, the total amount from 0 to 8, like we want to know how much in total, you're going to have to take the integral. Let me scoot this up. We're going to take the integral of 20 sine t squared over 35. Now, if this was original FRQ, you'll be able to put this in your calculator and be able to find the answer. But because the test that we're taking doesn't have a calculator, I'm sure if you were given a problem like this, that they would give you something that you can integrate. So take the integral, substitute in your 8, and subtract when you substitute in your 0. So the actual answer for this one, if you were to integrate from 0 to 8 hours, would be 76.570 cubic feet. Okay, so that means in total, that's the total amount of water that's just went into the pipe. Okay, that's how much the rain is just flowing in. Okay, now let's go to question B. Question B says, is the amount of the water in the pipe increasing or decreasing at this time? So right now we're talking about increasing and decreasing. So that means right away in my head, I know I'm talking about the rate. So how to, if you look at the other notes, we made some notes on increasing and decreasing. So let's write that. Soon as you see increasing, that means your slope is positive. And then if we're looking at decreasing, that means your slope is negative. Well, how do you find the slope? Well, the slope, you always find it from the derivative, right? So the slope, we always plug into the derivative, and whatever it comes out, that's going to let you know, is it increasing or decreasing? So right now, we're just going to use the equation that they gave us. Oh, they're talking about rate. That means I'm going to use the rate equation that they gave us. Let me put this. Okay, so the question is the amount of the water in the pipe increasing or decreasing? So right now, I have this pipe, and there's 30 feet of water in it. And they want to know if water's going into the pipe, that means water, if the 30 cubic feet, if 5 cubic feet goes in, that means it's 35. If 6 cubic feet, let's just make an example. If 10 cubic feet goes in, that means there's 40 cubic feet that went in the water, into the pipe. But then water's also coming out. So let's say 6 came out. Well, if we want to know if the water going in or out the water that's going in here, is this going up or down? It's going to determine which one is bigger. So right now, this would mean that more water is going in than coming out. So we need to find out which one it is. So we're going to take R of t, and we're going to plug in 3. So that means we're going to get 20 sine of 3 to the second power over 35. So this one, you can, if you have a calculator, you can actually pause the video and find that answer, right? So we have 9 over 35, take the sine of it, multiply it by 20. So once you plug this into your rate equation, you will get the answer. Look. You're going to get the answer 5.0864. But what does that mean? That means at 3 hours, how fast is the water coming in? That means 5.0864 cubic feet per hour is coming in. That's how much water is going in. So an hour goes by, this is how much is going in. Another hour goes by, this is how much water is going in. But we also need to find out how much water is going out. So that means we're not going to use R, we're going to use D. So we're also going to plug this into the equation for D. So we're going to say, all right, 3 cubed plus 0.4, 3 squared plus 0.96 times 3. So we're just substituting it into our rate equation. If you find this answer, out will come 5.4. Okay, so what does that mean? That means this is how much is coming out. So that I would almost say this is negative, right? So every hour, this is the amount of water that is coming out. So this 30 right here, every hour, it's decreasing by negative, or not decreasing, it's coming out by 5.4 cubic feet of water, right? So now you need to compare these two. Is more water going in or is more water going out? And as you can see, more water is coming out, which means that the original question, it said, is the water in the pipe? So is the 30 feet increasing or decreasing? Well, this water is going to start going down. So it's no longer going to be 30. It's going to be decreasing, like 29, 28. It's going to go down because more water is coming out. So how do we justify that? Since the amount of water coming out is bigger or more than the amount of water going in, the amount of water in the pipe is decreasing. And then let's look at T equals 3, okay? So that's how you answer that question. The water in the pipe 30, more is coming out. So we just looked at the rates. So now let's look at question C. Question C says, at what time is the amount of water in the pipe at the minimum? Boom. Soon as you see minimum, what's going in my head? How do I find minimum? Well, minimum, you find it by looking for critical points, right? So right here, we can look for critical points. You can also analyze your endpoints. And then we also, once you find your, how do you find your critical points? You find your critical points when the slope is 0 for the first derivative. Okay, so right now, critical point, boom, my slope is 0, so I need to take the first derivative, right? So that's going to be the minimum. Now, on this one, we need an equation to look at the original equation. We don't have the original equation. So when we make the original equation, we have the information from it. So we can say, let's just call it h of x. We're making an equation right now. The amount of water that's in the pipe. That's an ugly pipe. All right. So the amount of water that's in the pipe is 30. Boom. How much water went into the pipe? Well, the only way you can find out how much water went into the pipe is if you go to the previous equation for R of T. So that means whatever went, just like we found at the beginning, 75 went in over the total amount of 8 hours. So right now we want to find the original equation. So we're going to take this, but then we have to subtract what's coming out. Okay, so this is going to give me our original equation to find out how much water went in, not how fast, but how much, plus how much is in there. So how much went in, how much went out, how much was originally in there. So this will be our original equation. Now, how do we find the minimum? Well, if this is our original equation, so this is our original equation. This is graph 1, equation 1. That means in order to find the next equation, we need to take the derivative of it. So what is the derivative of 30? Well, that's going to be 0. So we don't need to write it. Now, what is the derivative of an integral? Now we're looking back at fundamental theorem of calculus, right? So if I take the integral and I'm taking the derivative of it, that means it's like multiplication, undoing division. These are going to undo each other. So right here, this is just going to leave you with R of t. So you could, if you wanted to, you could say from 0 to t. So it's like substituting back in that t. So we're left with R of t. This drops off. What's the derivative of this integral? Well, that's going to give you d of t, because that's the fundamental theorem of calculus. So this is our equation that we're going to use to find the minimum. Okay, so now I'm looking for a critical point. All right, so if I'm looking for a critical point, that critical points are where the slopes equal 0. So I'm going to take this and I'm going to substitute in a 0. Okay, and now what ends up happening right here, if you have your calculator, this is really saying 0 equals 20 sine of t squared over 35 minus, oh gosh, this is a long equation, minus okay. So you'd always need to watch those negatives because this would change that. But once you take this 0, you would put it in your calculator, right? Or if this was something on the test that they give you, something you can solve, you would solve this equation. So maybe you might have to factor, maybe they'll give you something. It will be something intuitive that you can do. But this one you definitely would put in the calculator, find your answer, and we're looking for what is the value of t. Once you find this answer, t is going to be 0. and T will also be 3.272. So what does that mean? That means on the original graph, so whatever the original graph looks like, that means at 0, 1, 2, 3, let's say, and at 3.272, that means that that's where they have some type of tangent line. I don't know if it's up here, but they have a tangent line where the slope is 0. So I don't know what it looks like, but that's what it's telling us. So it's a critical point. So the only thing we found is if it's a critical point, we haven't found the actual minimum. So right now what we're going to do is we're going to look at, because you can have a graph where this could be the minimum or the endpoint, the endpoint could be the minimum. You have to look at both. So let's put our endpoints from 0 to 8. And then we're also going to put from 0 to 8. And then let's also put our critical point. So we have our critical point, endpoint, because they told us it's from 0 to 8 hours. So now we need to compare what is the highest y value for whatever this function looks like. So at the 0, is that the highest y value? So now you need to ask yourself, what do I plug this x in? Do I plug it in the second equation, the first equation, the third equation? Well, whenever you're looking at the highest y value, now we're looking back at the original equation. So that means we have to go back to not this one, because that's looking at the rate, but we're looking for the y value of the original equation. You're going to have to use this one right here. So I'll show you an example of one you can do by hand. So if I say h of x equals 30 plus 0, oh, not h of x, sorry guys. I put t over here and I put x right here. So h of t, 30 plus 0 to t minus 0 to t d to t. So what's happening is if I plug in 0, let me pull it. All right, so if I plug in 0, that means 30 plus, I'm going from 0 to 0 of this integral, 0 to 0 of this integral. Well, we know 0 to 0, that's nothing. It has no area. So that's 0, that's 0. And then right here, it's just going to be 30. So I plugged in my 0 for the integral. So that means right now, this y value of the original function is at 0, 30. So now, the same thing for this one, you would plug in from 0 to 8, from 0 to 8, right? So we have this one from the beginning, the answer from 0 to 8. You would subtract this answer, okay? And you would plug in 8 into, after you find the integral of it, plug it in, you would actually get 48.544, okay? And remember, this is the original one that we talked about earlier. But they subtracted, this is the water going in, but the reason it's less because you have to subtract the water coming out. All right, and then lastly, you would plug in your critical point, and your critical point, once you plug it in, will give you 27.965. So now we're looking for the minimum. So the minimum would be this one right here, because this has the smallest y value. Okay, so we would say the minimum is at time 3.272. It didn't ask for justification. It just asked, where is it? What is the minimum? Oh, it did. It says justify your answer. So let's justify it. The minimum is at t equals 3.272. Okay. All right. Since, what do we plug it into? We made our equation right here. Since h of 3.272 has the lowest y value. Okay. All right. That is the end of that one. Let's look at the last one, which is going to be very quick because it says the pipe can hold 50 cubic feet. So right now it has 30. The max it can hold is 50. So it wants to know, when is it just going to start flowing over? Well, right now, this is talking about original. It's not saying how fast. It's not saying the rate. So that means I'm going to have to use, when will it be 50 feet? And what equation am I going to use? You're going to have to use your original equation. I have 30 already in the pipe. I need to find out how much is going into the pipe, which is going to be R of T. And we also need to find out how much is coming out of the pipe. So go to the original plus the original. And then we need to see from what amount of hours are we going to into the pipe. Oops. We would need to look for T. So when would it go over? When this equals 50, whatever this 30 is, that would be your original equation. Okay, so we don't know if this is 5, we don't know if it's 6, we're not sure, but we know that once it equals 50, that's when it flows over. All right, that is the end of free response 1.